So in this video, we're going to talk about surface area of pyramids and cones. And a reminder of what a pyramid is. Remember, it's just a polyhedron, and it has a polygon base. So the base is some shape that you're used to. And the faces, the lateral faces, are triangles. So you can see that these faces are going to be triangles here when we have a pyramid. Okay? And they all have a common vertex, so they all come to a point, which is what we've discussed. All right, now I really want to talk about height, because we have two different kinds of height in a pyramid or a cone. We have the height of the whole pyramid, so that goes from the base all the way to the vertex, like it's shown in that diagram. And then we also have what we call a slant height, and it's exactly how it sounds. It's a slanted height. It's not vertical up and down. And that's going to be the height of those triangles. You see how this is a triangle, and the slant height is just the height of that triangular face. All right, so think about it. If I were to unfold this pyramid, it would look like a square base, and then I have all of these triangles on the outside. Okay, so that height of that triangle is the slant part. So now let's talk about a cone. Remember, a cone just has a circular base, and it does have curved sides, so we don't have triangles now, but it's just, think of wrapping a piece of paper around, or like just, so again, we still have the height of the whole cone. So when we say height, we mean the height of the whole cone. And then we do have a slant height, and that's the slanted part of the cone, so like the outside part of the cone. And again, if I were to unroll this, I would have this circular base, and then I would have this is the cone part. This is like what we would hold on an ice cream cone. So if I were to roll that up, that would make an ice cream cone. All right, so that's some vocabulary for you. Let's talk about formulas. So the surface area of a pyramid is simply going to be the area of the base. So I've got the area of the base here, whatever shape that happens to be here, it's a square. And then I'm going to have 1/2 the perimeter of the base times the slant height. So this part right here, guys, that part is simply the area of a triangle, but we just have more than one of them. Remember, the perimeter adds up all those bases for us. So I have area of a triangle, remember, is 1/2 base times height. So that's what the 1/2 PL does. Okay. Now, if I use that formula, I'm going to read this. If I use that formula for the cone, then it's going to look a little different, because the area of the base of a cone is a circle. So this is going to be pi r squared. So surface area is pi r squared plus, I'm going to have 1/2. What is the perimeter of a circle? That's just the circumference. So that is 2 times pi times r. And then I have the slant height, the L. So if I were to simplify that, notice that I have 1/2 times 2. So if I do 1/2 times 2, that just gives me 1. So I can rewrite this formula for the cone as pi r squared plus, these two cancel out, they just give me 1. So I just have pi times r, the radius, times the slant height. Okay, so that's the area, the surface area formula we'll use for a cone. Okay, so let's look at some examples. So in these first two, we're just going to find the slant height of each figure, because sometimes they don't give you the slant height. Now remember, the slant height would be this part right here. That's the slant height. That's the cursive L. So in order to find that, I have to treat this pyramid like it has a triangle inside of it. So I have a triangle that's composed of the height of the whole pyramid. So that's the height of the whole pyramid, 100 feet. I've got the slant height, and then I have this this imaginary line that I'm drawing in that's going like halfway across that base. So if we think about it, it'd be going just like that much across the base. All right, but it's in here in the middle. So I'm going to redraw that triangle. So this side is 100 feet. This side is my slant height. And how big would this bottom part be? Remember, it's only going halfway across that base. So it's going to be half of 200. So that's going to be 100. And how do I find the third side of a right triangle if I already know two sides? Well, that's Pythagorean theorem. So we're just going to do Pythagorean theorem. A squared plus b squared equals c squared. And remember, c squared is your hypotenuse, and that's our slant height. So I'm going to do 100 squared, which is 10,000, plus another 10,000 equals L squared. So I have 20,000 equals L squared. And now I'm going to take the square root of both sides. So if I take the square root, remember that cancels. And the square root of 20,000 is about 141.42. And if I was doing units, this is just feet, right? The slant height is just in feet. So that's the answer to that example. And let's come over here to the cone. For the cone, the slant height is this part that you would hold on to if you were holding on to an ice cream cone. So that's my slant height. And notice that the radius makes the bottom part of this right triangle, and the height of the cone makes up the other part, the other leg of that right triangle. So I'm going to redraw this right triangle. And the bottom part is 3, the height is 4, and I'm trying to find the slant height. So again, we're going to do Pythagorean theorem. 3 squared plus 4 squared equals L squared. So I'm going to get 9 plus 16 equals L squared. So I'm going to move that up here. If I add those together, I get 25 is L squared. Square root each side, and I get L equals 5. So, and that's in centimeters. So my slant height is 5 centimeters. And that's all they wanted me to do on that one. So let's go down to some more examples. Here we're going to find the actual surface area of each pyramid. And remember, for when we find the surface area, I need 3 things. I need the area of the base, capital B. I need the perimeter of the base, and I need the slant height. So that's what we're going to find each time. All right, so if we look at our diagram, they gave us capital B already. So they gave us the area of the base, and keep in mind, the base is a triangle here. So that base is in the shape of a triangle. So I can write this is 35.1. The perimeter is going to be all of the sides added up. So I'm going to have 9 plus 9 plus 9. Or in other words, I'm going to do 3 times 9. So my perimeter is going to be 27. And then in this one, they actually gave me this height. They gave me that this is 12. So that's my slant height. I didn't have to do any work on that. That's nice. So that's 12. So now I'm just going to plug this into my formula. Remember, the formula is capital B plus 1/2 perimeter times slant height. So that's going to be 35.1 plus 1/2 times 27 times 12. So if I do all that, that's going to be 35.1 plus, I get 162. And that's going to give me 197.1 centimeters squared. Now this is surface area, so area is going to be squared units. Okay, so that's our surface area of that triangular prism. Moving on to number 4. I'm going to move these down a little bit, give me a little more room. So in number 4, again, we're finding area of the base, perimeter of the base, and slant height. All right, so my base is a square. So to find capital B, I'm just going to do length times width, or base times height, or side squared, however you want to think of it. So 7 times 7, which is going to be 49. So my B is 49. My perimeter is just going to be 4 of those lengths, so 7 plus 7 plus 7 plus 7, or 4 times 7. So that gives me 28. And again, they gave me the slant height right here. So that's my slant height, so I don't have to do any figuring there. So we're just going to plug this in to our formula. Surface area equals capital B, 49, plus 1/2 times the perimeter times the slant height. So I get 49 plus 126, and then that gives me 175. And my units would be inches squared. So my surface area of the square pyramid is 175 square inches. All right, last pyramid. Now in this one, it's also a square pyramid, but notice that they didn't give me the slant height this time. So we're gonna have to do a little bit more work. But let's start with our B. Our B, we're gonna find the same way. It's a square base. So I'm gonna do 6 times 6. And that's gonna give me 36 for my B. My perimeter is gonna be 4 of those 6s. So I'm gonna do 6 plus 6 plus 6 plus 6, or just 4 times 6. So that's 24. And for my slant height, I need to draw that right triangle like we did up above. So I have my height, I'm going to go halfway across my base, and then I'm going to have my slant height. So I'm going to draw that down here. So my height of my pyramid is 4. Halfway across is half of 6, so that's going to be 3, and this is my slant height. So we've already done this Pythagorean theorem up above, right above it. 3 squared plus 4 squared equals L squared. So you can see that we're going to get L equals 5. So L equals 5, our slant height. So now we have all of our pieces in order to do the surface area. So surface area is going to be 36 plus 1/2 times 24 times 5. So if I multiply those together, that gives me 60. Add them up, and I get 96 feet squared for my surface area. So those are our pyramids. Now let's go down to our cones. We're going to use that formula that we came up with. Remember that surface area of a cone is pi r squared plus pi r L. So each time I'm doing this, I don't need B, P, and L. I need just R and L. Remember, R is your radius. So in this first example, it gave me R. That's 4 inches. So this is my radius. And then it also gave me my slant height, my 6. So I just have to plug that in for my surface area. So I'm going to have pi times 4 squared plus pi times 4 times 6. So if I square 4, that's going to give me 16. I'm going to just write this as 16 times pi right now. And I'm going to multiply the 4 and the 6 together, and that's going to give me 24 pi. Now I'm just going to add 16 pi and 24 pi together, and that's going to give me 40 pi. And the reason I'm keeping pi in my answer is that because pi is estimated to be 3.14, so if I multiply it out, I'm going to have a rounded answer. So this is very exact, but I could get a decimal approximation, and that would be about 125.66. And again, the units on that would be inches squared. So my surface area is exactly 40 pi, or if I wanted a rounded answer, I would get 125.66. All right, so let's do the middle example. Section that off for us. All right, so we just need R, and we need our slant height. Now notice they didn't give us slant heights here. Okay, so we're going to have to use a triangle. Remember, this is our radius and our height. So my triangle is going to look like this. We're going to have 5 on the height side, 12 on the radius side, and L for the hypotenuse. So that's 5 squared plus 12 squared equals L squared. 25 plus 144 equals L squared. And that gives me 169 for L squared. Now don't forget to square root. So L is going to be 13. So I'm going to have 13 for L. And then my radius that was given, remember this is my radius. So we're just going to plug that into our formula. I'm going to scoot down and do that. So I'm going to have surface area equals pi times radius squared, so that's 12 squared, plus pi times my radius, which is 12, times my slant height, which is 13. So I'm going to square the 12, that's 144 pi. I'm going to multiply 12 and 13 together, that gives me 156 pi. I'm going to add those together, that gives me 300 pi. So that's my exact answer. And then the estimated answer, if I were to plug that into the calculator, that would be 942.48 feet squared. Our last example for cone. Notice that they gave us the slant height. They didn't give us the radius. So remember, the radius is always going halfway across that circle, but this is all the way across. That's the diameter. So the radius is going to be half of that 8, which is just 4. So my radius is 4, and this is my slant height. Slant height is 8. So not a lot of work to do there. That's nice. So my surface area is pi times 4 squared plus pi times 4 times 8. So I square the 4, I get 16 pi. Multiply the 8 and the 4 together, that gives me 32 pi. And then I'm going to add those together to get 48 pi. So my exact answer for surface area is 48 pi. And if I plug that into my calculator, that's going to give me about 150.8 feet squared. So here are a few examples for how to do surface area of prisms and cones, and then we'll do more examples in class.